This is the first video I'm going to do on redox, and in this video we're going to introduce the concept of oxidation number. Redox is a term that you will be unfamiliar with, but certainly you will have heard of oxidation and reduction processes. So oxidation is loss of electrons and reduction is gain of electrons. Okay. So oxidation numbers. Oxidation numbers are a measure of the number of electrons that an atom uses to bond with atoms of another element. Okay, now you can assign oxidation numbers to both ionic and covalent compounds. So it's a similar concept to the charge, but charges only occur on ions. Okay. Now, there's a set of rules that we have to obey. Now, this is a simplified set of rules. You can put more detailed rules together if you so wish. The first rule is this. Any element that is uncombined to another element, i.e. it only has a bond to itself, its oxidation number will be 0. You will encounter this most frequently with the elements such as like the diatomic molecules such as oxygen, nitrogen, fluorine, hydrogen, also things like sulfur 8. So although the atoms have bonds to another atom, because they are atoms of the same element, the oxidation number is 0. When hydrogen is combined to another element, such as in water or ammonia, its oxidation number is usually, I'm talking 99% of the time, it will be +1. There is an exception though, and that is when hydrogen bonds to metals such as sodium or calcium and makes compounds called metal hydrides. So this formula here is sodium hydride, this one here is calcium hydride. And in this case, the oxidation number of hydrogen is -1. When oxygen is combined to another element, its oxidation number is -2. And this kind of stands to reason for ionic compounds, because the charge of an oxygen in an ionic compound is -2. But also, the oxidation number is -2 in water. There are 2 exceptions we need to be aware of. The first exception is in peroxides, where there's an oxygen-oxygen bond, but each oxygen is bonded to a hydrogen, and this means that the oxygen, or each oxygen atom, has an oxidation number of -1. Examiners like to use that because they're trying to catch you out, basically. In the molecule fluorine oxide or difluorine oxide, fluorine has got an oxidation number of -1 and oxygen has an oxidation number of +2. When fluorine is combined to any other element, its oxidation number is always -1. There are no exceptions. Elements of the other halogens, such as chlorine, bromine, iodine, have variable oxidation numbers. I will see that a little bit later on. The ions have a... when we're looking at ions, the charge on the ion is the same as its oxidation number. So, sodium's in group 1, forms +1 ions, therefore its oxidation number will be +1. When magnesium makes a compound, because it's in group 2, it has a charge of 2+ in its ion, its oxidation number will be +2. Now, this is the important bit down here. The sum of the oxidation numbers for each atom must equal the charge on that species. So here we can see that in water, we've said that hydrogen has got so there are 2 hydrogen atoms, each with an oxidation number +1. Oxygen has an oxidation number of -2. there is no charge shown up here, so therefore it's a neutral molecule. So the sum of the oxidation numbers equals the charge. So just let's have a quick look at a few more examples. Sulfur dioxide up here at the top of the page. The question could be, what is the oxidation number of sulfur in this compound? Because sulfur is able to adopt a few different oxidation numbers. So we know that oxygen has an oxidation number of -2. There are 2 oxygens in this molecule, and we can see that up here there is no charge. So the sum of the sulfur plus 2 lots of oxygen, or 2 lots of -2, equals 0. So that means that sulfur must equal +4. We'll look at a couple of ions. The carbonate ion. Now we've got an ion with a charge of 2-. We know that when oxygen combines, its oxidation number is -2. Therefore, carbon plus 3 lots of -2 equals the charge of -2. So the alternative way to think of that is carbon plus -6 equals -2. Add 6 to both sides. Carbon has an oxidation state of +4. Okay. Just a quick word that the terms oxidation state and oxidation number are interchangeable. They mean exactly the same thing. Finally, this example here, we've got a dichromate ion. Okay, so it's Cr2O7. It's got a charge of 2-. Each oxygen has a charge of an oxidation number of -2. So we've got 2 chromiums plus 7 lots of -2 equals the charge, which is -2. That simplifies to 2 chromiums minus 14 equals -2. Add 14 to both sides. 2 chromiums have a combined oxidation number of +12. So therefore, each chromium atom is half of 12. So that is, each chromium atom has an oxidation number of +6. Okay. In the past, we've talked about transition metals and the Roman numerals, and we've said that the Roman numerals equates to the charge on that metal ion. That was a slight mistruth. It's more accurate to say that is the oxidation number. So iron 2 chloride, the oxidation number of the ion is +2. Iron 3 chloride, the oxidation number of the ion is +3. Okay, so here we've got the oxy-ions. Oxy-ions are when you have got a negative molecular ion that combines oxygen, which is combined to a second element. Usually it's sulfur, phosphorus, carbon, nitrogen. Sometimes it can be a metal such as manganese. Those are the most common ones. Now, the IUPAC names for these compounds here containing sulfur and oxygen are that they are both sulfates. In the older nomenclature, this used to be called a sulfite, the SO3 2- ion. Okay. We need to be able to distinguish between these two different sulfates. We do that by looking at the oxidation number of the sulfur. So as we've done previously, we say sulfur plus 4 lots of -2, which is -8, equals the charge of the ion, which is -2. Add 8 to both sides. The oxidation number of sulfur is +6. If you go through the similar process for this ion dissolved, what we used to call sulfite, you find that the oxidation number of sulfur is +4. And we put the Roman numerals after the word sulfate to denote the oxidation number of the non-oxygen atom. So in this case, the sulfur in this compound here, it would be the 5 refers to the the nitrogen in nitrate. This substance here, potassium manganate 7, the 7 refers to the oxidation number of the manganese. Okay, and that concludes this video for now. Thank you for listening.